Hello guys, you're welcome to God Academy. In this lesson, we will explain the difference between symmetric and antisymmetric properties of numbers. In order relation, when we are talking about order relations in numbers, we are talking about how two numbers are connected or associated. You can have equal to, you can have less than, you can have less than or equal to, and so on and so forth. But when do we say that any of these relationships here are symmetric, or any of this is symmetric or anti-symmetric or any other, right? Now let's delve deeper into symmetric. So talking about symmetric properties, for symmetric property, it's a simple rule. It says, or we can call it reversible, okay? That will make you understand it so well. So when I talk about symmetric property, just imagine reversibility. If I have two numbers, A and B, which are members of a bigger set A, talking about the order relation R on these sets, we are going to see that when I have A to be equal to B, right, and B to be equal to A, provided the use of R. So simply I'll say that A R B. So for A R B to be equal to B R A, then B should be equal to A should be equal to B. It's talking about reversibility. The R here stands for any relation equal to, less than, or any relation of a sort. So if the first number is related to the second number in this way, then if I remove the first from its position and put the second as here, like B, relation A, it should always make sense and be equal. So it's talking about reversibility. Okay, so the equal to sign is a typical symmetric relation, so that any two items related by equal sign would be equal in opposite direction. Now let's also analyze antisymmetric. So when it comes to antisymmetric, what are we trying to do here? Take note, for the very first one, take note that symmetric is not the opposite of antisymmetric, neither vice versa. So symmetric and antisymmetric are not the same. Take note, are not the same. Okay, sorry, are not opposite. That's what I'm trying to say. So antisymmetric, the word anti here doesn't necessarily mean that they are opposite. Okay, are not opposite. It's one thing that confuses students a lot, that once I hear symmetric and now you're talking about anti-symmetric, then it means that they are opposite, but that is a false statement. So now what then is anti-symmetric? For the same set I have here and the same relation, if I have A relation B going into B relation A, how then will I say this exhibit an antisymmetric property? Antisymmetric property simply says that for you to reverse any two numbers with a relation, then the two numbers can only be swapped, okay, can only be swapped or can only be interchanged when the two numbers are equal. Let me write the condition well. So the condition is that the two numbers A and B can be swapped, or they can be interchanged. Let me write it here, interchanged, if A is equal to B. So have you seen how it's working here? So meaning that I can only swap any two numbers with a relation. I can only interchange their position provided they are equal. So antisymmetric is talking about a restrictive law here. So meaning that if I have equal to as an operation or as a relation, so far as I can swap it, then it means they are equal. Okay, let me put it this way. So this is the thing. So if you have A, which is relating to B, okay, and B relating to B, what this thing is telling us is that it has been swapped, the position has been interchanged. But antisymmetric is telling us that we can only do this swapping provided A and B are equal. Okay, if A and B are not equal, our relation still holds. Please take note. But symmetric property tells us that you can't, so I mean, swap it. Uh, whether it's, I mean, okay, let me say it this way. Sorry for the confusion. So symmetric property is telling us that for any relation to be symmetric, then with no compromise, the two numbers should be equal in both sides of the relation. That is all. So at all costs, the two should be equal for it to exhibit symmetric. But antisymmetric says that the two of them are not necessarily going to be what? Equal for the relation to hold. But it can be swapped provided the two numbers are equal. A typical example, I can have 2 less than or equal to 5. When I say 2 is less than or equal to 5, the opposite end will be 5 less than or equal to 2, right? When I say 2 less than or equal to 5, and I interchange and I had 5 less than or equal to 2, you realize that they are not true. This is not true. I mean, the first way around, it makes sense. The second way around, it doesn't make sense. Meaning, this one is not symmetric. So, it is not symmetric. But when you talk about antisymmetric, yes, 2 is less than or equal to 5. When you swap it is 5 less than or equal to 2. But you cannot swap because they are not equal. So antisymmetric will tell you that don't swap, but this still holds. So meaning less than or equal to satisfy the antisymmetric property. Don't swap, it still holds. I don't know, it still holds. Don't swap. You can swap only when they are equal. That is antisymmetric. It's only trying to tell you that don't swap only when they are equal. But that doesn't mean that if they are not equal, it doesn't hold. It still holds, right? So we have equal to, we have less than or equal to as antisymmetric properties. Or sorry, as exhibiting antisymmetric property. While symmetric property only goes for equal to, because that one it will tell you that for you to call me symmetric, it means that we are equal in two ways. But antisymmetric will tell you that you can only be equal when you have been swapped, and I mean when you have swapped, like you can only swap me when you are equal. But if you have not swapped and you are, because you are not equal, fine, you are still antisymmetric. So I want you to appreciate the fact that antisymmetric is not opposite of symmetric, but it's an adjusted form of symmetric. So we have adjusted the symmetric relation so that it can accommodate a situation where they are not the same but can only be swapped with certain conditions. And I think this should satisfy or clarify your doubts and confusion about symmetric and antisymmetric. For anything, please drop in the comment section any form of misunderstanding here, and it will be looked at in the next lesson. Stay glued to your seat and make sure you watch this video to the end. Thank you so much. Bye bye.